Hi, in this video, we will see a question from electrostatics. Okay, two identical charged spheres are suspended by strings of equal length. Two charged spheres are there; they are suspended by strings of equal length. Okay, so just I'm going to draw the diagram for the first line. This shows the fixed support from which two charged spheres are suspended. Say this is sphere 1 and this is sphere 2. These two spheres are identical. Okay, so they repel each other. They cannot stay in the same place together. They repel each other, and the strings make an angle of 30 degree from each other. The angle between them is 30 degree. Okay, when suspended in a liquid of density 0.8 gram per centimeter cube. Okay, in the first case, these two spheres are suspended in air medium. In the second case, the same setup is suspended in some other liquid. Its density is 0.8 gram per centimeter cube. The angle remains same. In that case also, the angle is same. If the density of the material of the sphere is, the sphere density is given, that is 1.6 gram per centimeter cube. The dielectric constant of the liquid is, we have to find the K value, dielectric constant K value. Okay, so let me explain the question again. Here we have two identical spheres. Initially they are suspended in air medium. Due to the repulsive force, they will move apart from each other. Okay, that angle is 30 degree. If the same setup is suspended in liquid, if still that angle remains same. Okay, that's the condition given. Okay, so and the density of material is also given. We have to find the dielectric constant of that liquid. Simple. Okay, so here we can split the question into two cases. In the first case, we will form the equation for the air medium. In the second case, we will form the equation for the liquid medium. Okay, then we can combine. We will find the common factor between those two and combine those two equations to solve the value of K. Okay, so first take the case 1 when they are suspended in air medium. So case 1, both spheres are in air medium or vacuum. If the medium is not mentioned, you can take that as air or vacuum. Okay, in the first case the medium is not mentioned, so we have to assume air or vacuum. Okay. We have to draw the free body diagram for this case to identify the forces acting on those two spheres. Okay, this is sphere 1. The first force is self weight. Its own weight will act in downward direction, and the tension in the string, it acts towards the source, and we can assume an angle here for our reference. This could be theta, and this value will be t times sine theta, and the vertical one will be t cos theta, and the electrostatic force will be F. Okay, we can frame the equation with this. Let's equate the horizontal forces. We will get F is equal to T sin theta, equation 1, and just equate the vertical forces. You will get T is equal to, T cos theta. mg is equal to, downward force is equal to T times cos theta. This is equation 2. Okay, so I just equated the vertical and horizontal forces. So left side force is equal to right side force, and upward force is equal to downward force. Now we can divide the equation 1 and 2. So you will get, dividing equation 1 and 2, you will get F by mg is equal to T sin theta divided by T cos theta. You can cancel the t on numerator and denominator. You know the sine by cos value is tan theta. Okay, then f by mg is equal to tan theta. You can name this as equation 3. Okay, just keep this aside and we will do the same thing for the second case. Okay, second case, the setup is immersed in a liquid. Here the medium is liquid. You can have the same diagram. You should have the same diagram. The same spheres are suspended. The same forces will act. That this one is t cos theta. You can copy the forces from the first diagram. Okay, no need to reconsider it again. And this will be f dash, because initially they are in the air medium, so electrostatic force I have taken as f. Okay, so in the second case the medium changes, which means the electrostatic force also change. Whenever the medium change, the electrostatic force also change. Okay, to point out the difference, I have taken the force value as f dash. Okay, and this will be t sin theta, and this will be self height. Along with that, a buoyancy force will act, upward force, a buoyant force will, because the setup is immersed in liquid, so you will have an upward buoyant force. Okay, this is the only difference. You have the all other forces remains the same except the buoyant forces and the f dash value. Okay, now you can frame the equation for the second case. Equate the horizontal forces. You will get f dash is equal to t sin theta, and let's take this as equation number 4. Equate the upward force. The upward forces are t cos theta, and the buoyant force, it is also acting in upward direction. F buoyant is equal to, and the only downward force is m into g. Okay, now we have to find the value of this buoyant force. You know, if something is immersed in a liquid medium, an upward force will act. Any fluid, you know, upward force will act. That force is called buoyant force, and the value of this force is equal to, this upward force is equal to the volume of the object. It is the object's volume. This object's volume is v. Let us take the object volume as v, and it is multiplied with the density of the liquid and the gravity g. Okay, acceleration due to gravity. So if you multiply the volume of the object and the density of the liquid along with the gravitational acceleration, you will get the buoyant force value. You might have read this in fluid mechanics topic. Okay, so let's substitute this value. We will get t cos theta plus v sigma into g is equal to mg. Here the sigma indicates the density of the fluid. Okay, density of the liquid in which the setup is immersed. Okay, I'm just rewriting this equation. T cos theta, you know the volume formula, volume and density formula. Rho is equal to m by v, and you can rearrange this. You will get v is equal to m by rho. Okay, so m indicates the mass of the sphere, rho indicates the density of the sphere, and sigma indicates the density of liquid, and g is here. You will get equal to mg. Okay, so I just replaced the fb force with volume of the sphere and density of the liquid into gravity. This is the formula for buoyant force, and again I replace the volume of the sphere in terms of mass. Okay, so that I can cancel the terms. Okay, so let's take this term to the right side. They will get t cos theta is equal to mg minus mg sigma by rho, and you can take the common terms, m and g as common. You can take that out. You will get t cos theta is equal to mg. If the mg is removed in the first term, you will get only 1. If the mg is removed in second term, you will get sigma by rho. Okay, sigma by rho. Now you can take this equation as equation 5. Now you can divide the equation 4 and 5. We will get, dividing equation 4 and 5. Equation 4 is f dash equal to t sin theta. F dash is equal to t sin theta. And the second equation, I am writing the theta terms on the right side, so that I can get the tan theta at the end. So mg 1 minus rho is equal to t times cos theta. So if you divide these two, you will get f dash by mg 1 minus sigma by rho is equal to, this t and t will get cancelled, sin by cos value will become tan theta. This is equation number 6. Okay, now you can compare the equation 3 and equation 6. Okay, you can have the tan theta value. So tan theta is common because in the question itself it is mentioned theta value remains same. The angle between the two spheres remains same even they are shifted to the other medium. So we can equate these two equations, equation 3 and the equation 6. You will get f by mg is equal to f dash by mg into 1 minus sigma by rho. We know the electrostatic force when those two spheres are suspended in liquid medium is given by the electrostatic force when they are in air divided by dielectric constant of the liquid. Okay, dielectric constant of the liquid. And let's take the dielectric value as k. So f dash is equal to f by k. Okay, so we can just replace it. We will get f by mg is equal to f by k mg 1 minus sigma by rho. Now you can cancel the things on both sides, f and f, mg and mg. So you will be left with 1 is equal to 1 by k 1 minus sigma by rho. We have to find the value of k. Then we can simply take this to this side. We will get k is equal to 1 by 1 minus sigma by rho. Okay, so let us substitute the value of rho and sigma given question. The value of rho is 0.8. Here the density of the sphere is 1.6 and the density of the liquid is 0.8. Let us substitute the value. Density of the liquid is 0.8 and the density of the sphere is 1.6. Okay, so before substituting you have to make sure these two values are in the same unit. If they are in different units you have to convert them into same units. Okay, and you can rearrange this. You will get 1 divided by, and you can rearrange this 1.6 minus 0.8 by 1.6. You will get 1 divided by 1.6 minus 0.8 is 0.8 divided by 1.6. You can cancel, this will be 2 times of this, so you will get 1 divided by 1 by 2. You can take this 2 to the numerator, you will get 2. So k value is 2. So this is in option D. The required dielectric constant is